Hello everyone, myself Vinay Kumar. I am actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, mathematics, then please do subscribe to my channel. So till now I was actually teaching the 8th standard mathematics subject, in which I have already taught two chapters, that is first and second. So now I am actually teaching the third chapter, that is quadrilaterals. So in this quadrilaterals chapter I have already completed two parts. So you can refer part 1 and part 2 videos of quadrilaterals, where you can understand the concepts of quadrilaterals, polygons and etc. So along with that I have also solved exercise 3.1 and exercise 3.2 in part 1 video. So after referring part 1 and part 2 video, you can come to this part 3 video and understand the further concepts of quadrilaterals. Where here in this part 3 I will be explaining exercise 3.3 and exercise 3.4, which was actually left out. Coming to exercise 3.3, in that first question, they have actually given a parallelogram. So, after giving the image of a parallelogram, they are actually asking to complete these four questions by using the properties of parallelogram. So, now let us look the first question which is there in this particular first question. So, here AD is equal to dash. So, in this dash, you should actually put which will be much more suitable, which is actually equal to AD. So according to the property of parallelogram, opposite sides of a parallelogram will always be equal. So if this is AD, then this is BC. So AD should be equal to BC. So opposite sides are equal, hence AD is equal to BC. So coming to the second question, DCB. So this particular angle. So DCB. So this particular angle should be equal to the opposite angle DAB. Because in parallelogram, opposite angles should be equal. So here DCB will be equal to DAB. Similarly, OC is this particular length. So we know that in parallelogram, diagonals will bisect each other. That means OC must be equal to OA. So here OC is actually equal to OA. Now coming to the fourth question, here you have MDAB plus MCDA is equal to dash. So here MDAB means this particular angle and MCDA means this particular angle. So always in parallelogram, adjacent angles will be supplementary to each other. That means if you add adjacent angles, then that should give you 180 degree. So here they have given M and M. So that shows here it should be 180 degree. So if you add angle DAB and CDA, which is the adjacent angles, you should always get 180 degree. So the answer for this fourth question is 180 degree. So coming to the second problem in this particular exercise 3.3. So you have 5 different problems where they have given 5 different parallelograms and they have actually asked to find x, y, z in that particular question. So coming to the first question in this particular second question. So we have 5 questions in this particular second question. I will be solving 3 questions. Remaining 2 questions you can actually solve. So coming to the first question, you have this particular parallelogram where they have given angle of one angle in this particular parallelogram. So here you should find x, y and z. So angle ABC is actually 100 degree. So the given data is actually angle ABC is actually equal to 100 degree. So according to one property of parallelogram, here adjacent angle should be supplementary. So in a parallelogram, adjacent angle should be supplementary. So that means adjacent angle of this particular ABC is DCB, that is x. So that means ABC plus x should be equal to 180 degree. So now let us solve this. So we will take ABC on right hand side. So it will be 180 degree minus ABC. So now let us subtract 180 degree minus ABC. So ABC is actually 100 degree. So 180 degree minus 100 degree will give you 80 degree. So the value of x is actually equal to 80 degree. Similarly, now let us solve the y as well. So here anyway x is 80 degree means the opposite angle should also be the same. According to property of a parallelogram, opposite angles in a parallelogram are always equal. So that means opposite angle in parallelogram are equal. X is actually equal to Z, which is actually equal to 80 degree. So if X is equal to Z is equal to 80 degree, then here also you can see ABC is opposite to this particular Y. So that means this Y is actually equal to 100 degree because the opposite angles are equal. So here ABC is actually equal to Y, which is actually equal to 100 degree. So X is 80 degree, Z is 80 degree, Y is 100 degree in this particular first problem. Coming to the third question in this particular second question, you have given this particular parallelogram. So here they have given this as 30 degree, this as X and this as Y and this as Z. So now we have to find X, Y, Z. And here they have given this particular diagonals are actually bisecting each other in such a way that they are actually right angles to each other. So this particular angle is actually 90 degree. So if this particular angle is 90 degree, then its opposite angle, this X, should also be 90 degree because this is a parallelogram. So in parallelogram, these two particular diagonals are actually bisecting each other, and here according to the given data, here one particular angle, this particular angle is 90 degree. That shows this particular diagonals are actually perpendicular to each other. DOC should be equal to AOB. So that means here DOC should be AOB and AOB is actually X. So here DOC is actually 90 degree. So 90 degree is equal to X. So therefore X is equal to 90 degree. So now we have got the value for X. So now let us find Y and Z in this particular problem. So since this AOB is forming a triangle, so we all know the interior angle, sum of interior angles of a triangle should always be equal to 180 degree. So now we know X and we know this particular angle is 30 degree. So we can easily find what is Y. So here in triangle AOB, we have ABO as 30 degree. So the angle ABO is equal to 30 degree and X is actually equal to, we have found out that as 90 degree. So X is equal to 90 degree. So similarly we can find Y. X plus Y plus ABO should be equal to 180 degree since this particular triangle AOB is actually a triangle. So interior angles of triangle is equal to 180 degree. X is actually equal to 90 degree. Similarly, Y we don't know. ABO is actually equal to 30 degree, which is equal to 180 degree. So 90 degree plus 30 degree is 120 degree. So 120 degree, if you take that to RHS, then it will become 180 degree minus 120 degree. So Y will be equal to 60 degree. So if Y is actually equal to 60 degree, then you can see here opposite sides of a parallelogram should always be parallel to each other. So here AB and DC is actually opposite sides. That means here Y and Z are acting as alternating angles for in between this AB and DC, these two parallel lines. So here I'll just draw the diagram. So AB is like this, DC is like this. So this particular line is actually joining this AB and BC. So this particular angles will act as alternating angles. So since this is the symbol for since. So since AB is parallel to DC, here Y and Z act as alternating angles. So here Y and Z are alternating angles. So since Y and Z are alternating angles, here Y and Z should be equal. So what is the value of Y? We have found that to be 60 degree. So Y is equal to Z is equal to 60 degree. So here Y value and Z value is 60 degree and X value is actually equal to 90 degree. So X is 90 degree, Y is 60 degree, Z is 60 degree. So coming to the fifth question in this particular second question, we have a parallelogram like this where we have to find X, Y and Z. So here let us name this parallelogram as A, B, C and D, where AB is parallel to DC. So here there is a diagonal actually joining these two particular ends of parallelogram, that is D and B. So here this particular angle ADB is actually equal to 40 degree. Now we know that adjacent angles in parallelogram are supplementary. So I'll just write that since adjacent angles are equal to are supplementary. So adjacent angles are supplementary. That means DCB plus ADC. So this particular angle and this particular angle, this complete angle ADC should be actually summing up to 180 degree. So here DCB is actually 112 degree and ADC is there as it is. So now let us find what is ADC. So we'll take this 112 degree to RHS. So when you take 112 degree to RHS, it will become 180 degree minus 112 degree. So ADC will be equal to 68 degree. So if ADC is equal to 68 degree, then here they have given one particular angle is 40 degree and we have to find Z. So that means this ADB plus Z will be equal to 68 degree. So this ADC we can write it as, because here you can see ADC is actually equal to ADB plus BDC, that is actually Z. So ADB plus Z will be equal to 68 degree. So ADC can be written as ADB plus Z, which is equal to 68 degree. So now you can easily find Z. You can bring this ADB to RHS. So 68 degree minus ADB. So ADB is actually given, that is 40 degree. So 68 degree minus 40 degree. So here the answer is 28 degree. So Z is actually equal to 28 degree. Here you can see in this particular parallelogram, AB is actually parallel to DC. Since AB is parallel to DC, this particular X and this particular Z will act as alternating angles. So since this is the symbol of since AB is actually parallel to DC, here X and Z are actually alternating angles. I'll just write like this. So X and Z are alternating angles. So therefore X should be equal to Z, which is actually equal to 28 degree. Now let us find Y. Y is actually very easy because in parallelogram opposite angles are equal. So here we know that BDC is equal to 112 degree, then Y should also be equal to 112 degree. According to the property of one of the property of parallelogram, opposite angles are always equal. So opposite angles are equal in a parallelogram. Hence Y is actually equal to 112 degree. So now you have got answer for Y, you have got answer for X and Z. So X is 28 degree, Z is 28 degree and Y is 112 degree. So coming to the third question, they have given 3 questions in this particular third question, out of which you should actually, by looking at that condition which is given in those 3 problems, you should say whether a quadrilateral ABCD can be a parallelogram or not. So coming to the first question, they have actually given angle D plus angle B is equal to 180 degree. But if you draw a quadrilateral something like this, which is almost similar to parallelogram, sometimes opposite angles might be equal to 180 degree. But here they have not given the condition where D and B are equal to each other. The sum of D and B is 180 degree. But actually they are not equal. They have not mentioned here that these particular D and B are equal to each other. So that means sometimes this can be a parallelogram and sometimes this cannot be a parallelogram. So answer for this first question is it can be a parallelogram, or sometimes it cannot be, it can't be a parallelogram as well. So coming to the second question, here they are given AB is equal to DC is equal to 8 centimeter, AD is equal to 4 centimeter and BC is actually equal to 4.4 centimeter. So if we are considering a quadrilateral ABCD like this, so here actually ABCD is a quadrilateral where AB and DC are equal to each other. But here you can see AD and BC are not equal to each other. In a parallelogram, opposite sides should be equal to each other. But here you can see AD is 4 centimeter and BC is 4.4 centimeter. So that's why this particular quadrilateral in this second problem cannot be a parallelogram. Cannot be a parallelogram. So here also in third question you have second question, in that also this particular quadrilateral cannot become a parallelogram. Coming to the third question, in this particular third question, A is actually equal to 70 degree and C is actually equal to 65 degree in a quadrilateral ABCD. So if we consider this as a quadrilateral A, B, C and D, then here A is actually equal to 70 degrees, C is actually equal to 65 degree. Here you can clearly see angle A is not equal to angle C. Therefore, this is not a parallelogram. So this particular third question also, the quadrilateral which is given is not a parallelogram. So this can be the answer for your third question. So coming to the fourth question, here they have given you should actually draw a rough figure of a quadrilateral which actually have opposite angles equal to each other, but that should not be a parallelogram. So you know that in kite we have this kind of image where two adjacent sides are actually equal. So these two sides are equal and these two sides are actually equal. Here in kite opposite angles are actually equal. So kite can be one of the example for this fourth question, which is not a parallelogram and still opposite angles are equal in this particular quadrilateral. So kite is an example for this fourth question. Coming to the fifth question, they have given in a parallelogram the ratio of adjacent angles is actually 3:2. So let's draw a parallelogram like this. So let's say this is a parallelogram A, B, C, D. So if we see the data which is given in this particular fifth question, they are saying the ratio of adjacent angles are equal to 3:2 ratio. So that means this particular A and B acts as adjacent angles of this particular parallelogram. So if you actually divide A by B, then the ratio is actually 3:2. So that gives you 3/2 as your answer. Like A by B is actually equal to 3/2. So now you should actually find out what is the value of A and what is the value of B. So this is one particular equation which we have. Similarly, we have another property in this particular parallelogram where A plus B is actually equal to 180 degree. Since adjacent angles of parallelogram are supplementary to each other, so if you add adjacent angles, that will be actually equal to 180 degree. So now using this particular equation and this particular equation, you can actually easily find out what is A and B. So let us see what is A in this particular case, or else we can just directly substitute this B in this particular equation. So let us take equation 1. So equation 1 states that A by B is actually equal to 3/2. So that means angle A is actually equal to 3/2 into angle B, because when you bring this divided by to the right hand side, then it will become multiplied by. So here A divided by B, B is actually brought to right hand side, so it became multiplied B. So into B. So 3/2 into B is actually equal to A. So let us say this as equation 3. So now you can actually substitute this equation 3 in equation 2. So if you actually substitute equation 3 in equation 2, so in this particular equation 2, you should actually substitute this A by this particular value, because here equation 3 is actually substituted in equation 2. So in the place of 3/2 B, in the place of A, I am actually writing 3/2 B plus B is actually equal to 180 degrees. So equation 2, we are actually substituting equation 3 in equation 2. So 3/2 B plus B will be equal to 180 degree. Now we can take B common in this particular equation. So if you take B outside, then inside bracket you will be having 3/2 plus 1, which is actually equal to 180 degree. So now you can solve this particular fraction by taking LCM. Here it is actually 1 means 1 by 1. So LCM of 2 and 1 is 2. So you can multiply that LCM with this 3/2. So 2 gets cancelled and 3 will be there. So plus 1 into actually 2. So 2. So 3 plus 2 by 2 will be the answer for this particular solving of this particular fractions. So 3 plus 2 is actually equal to 5. So 5/2 will be there. So that is actually equal to 180 degree. Now you can bring this 5/2 to our right hand side. So here 2 is actually there in denominator. So that will actually go to numerator and multiplied. So here 5 is there. So 5 will actually go to denominator. So whenever you bring fraction from LHS to RHS or RHS to LHS, then numerator and denominator gets interchanged. So here 5/2 becomes 2/5. So now you can easily solve this particular problem. So 2, you cannot cancel this. So 5 ones are 5, 3s are 15, 30 is there, 6s are 30. So 36 into 2, here 2 is there. So 36 into 2 is actually 72 degree. So here one of the angle is actually equal to 72 degree. If this is 72 degree, then we know that a plus b according to equation 2, a plus b is actually equal to 180 degree. Now we have got the value of b, that is actually equal to 72 degree. We can substitute that here in equation 2. So a plus 72 degree is equal to 180 degree. If you bring this 72 degree to RHS, it will become minus 72 degree. A is actually equal to 180 degree minus 72 degree. So that is actually equal to 108 degree. So here the answer for A is 108 degree and the answer for B is actually equal to 72 degree. Here A is actually equal to C and B is actually equal to D, since opposite angles are equal in this particular parallelogram. So opposite angles are equal in parallelogram. So the answer for this particular fifth question is A is actually equal to 108 degree, B is actually equal to 72 degree, C is 108 degree and D is 72 degree. So in coming to the sixth question, they have given a parallelogram where adjacent angles in this particular parallelogram are equal. So that means if you have a parallelogram A, B, C, D, then A and C will be opposite angles, B and D will be opposite angles, where A and B will act as adjacent angle, C and D will act as adjacent angle, B and C will act as adjacent angle, A and D will act as adjacent angle. So here adjacent angles are equal. That means A should be actually equal to B. So this is one particular data which has been given in the sixth question. And we also know that A plus B should be equal to 180 degree because adjacent angles in a parallelogram is supplementary to each other. So since A plus B is actually equal to 180 degree and A is actually equal to B, so you can write this as A plus A. Since B is actually equal to A, in the place of B you can write as A. That is actually equal to 180 degree. So A plus A is actually 2A is equal to 180 degree. So if 2A is 180 degree, then A is actually equal to 180 degree divided by 2. So that will be equal to 90 degree. So if A is equal to 90 degree, then B is also equal to 90 degree. So if B is also equal to 90 degree, then C and D should also be equal to 90 degree. Because here also you can see C and D are adjacent angles. So C plus D will be 180 degree and C and D should be equal because they have given adjacent angles are equal. So here C is equal to D. So here also you can take C plus C is equal to 180 degree since C is actually equal to D. So 2C is 180 degree, that means C is also equal to 180 degree by 2, that is actually equal to 90 degree. So this shows C is also 90 degree and D is also 90 degree. So all the angles in this particular parallelogram or in this particular quadrilateral ABCD is equal to 90 degree. So here actually coming to the seventh question, they have given a parallelogram HOPE. So in this particular parallelogram, you should find x, y and z and you should also state the property which you are using to find this particular x, y, z. So now let us see here, since HOPE is a parallelogram and this is actually an extension, we will just name this point as D. So since HD is actually a straight line, this particular POD plus HOP should be equal to 180 degree, the sum of these two. That means sum of HOP plus DOP should be equal to 180 degree since this HD is a straight line. So if this is 180 degree, then here we know POD or DOP is actually equal to 70 degree plus HOP. So here you can easily find HOP by bringing the 70 degree to RHS. So HOP will be equal to 180 degree minus 70 degree, that is actually equal to 110 degree. Now you have got HOP. Now you should actually state the property to find x. Since opposite angles, so this is one particular property which you can properly write in a statement form. I will just write the short form of this particular property. So opposite angles are equal. So opposite angles are equal in parallelogram. So you can state this particular property, and according to this particular property, HOP should be equal to X. So that is actually equal to 110 degree. So now you have found X. Now you can easily find Y and you can also find Z. Here this particular X and this particular EPO acts as adjacent angle. So X plus EPO should be equal to 180 degree. So here also one property you can state, which is actually adjacent angles in a parallelogram are supplementary. So adjacent angles are supplementary. This particular property also you can state here. So X plus EPO is actually equal to 180 degree. So you know the value of X, that is 110 degree, plus EPO is actually equal to 180 degree. Now you can easily find out EPO, that is actually equal to 180 degree minus 110 degree. So EPO is equal to 70 degree. So now you have found out that EPO is equal to 70 degree. Now let us go to the next property, where actually this particular 40 degree is actually equal to this particular Y, because EP is actually parallel to the opposite side HO. So EP is actually parallel to HO. This is actually one particular property of parallelogram which you can state, because opposite sides of a parallelogram are parallel to each other. So 40 degree will be equal to Y, because Y and this particular 40 degree. So 40 degree is actually PHE. So PHE, Y and PHE acts as alternating angles since EP is parallel to HO. So these two are alternating angles, hence Y will be equal to PHE. PHE is actually 40 degree. So Y is actually equal to 40 degree. So now you have got Y. So similarly you can actually calculate Z also. So here we know we have calculated EPO as 70 degree. So we can state another property of a parallelogram, where opposite angles of parallelogram are equal. So in a parallelogram opposite angles are equal. So this particular property you can actually state. So according to that, the EPO which you have found out here, which is equal to 70 degree, is actually equal to OHE. So that is actually equal to OHE. So here you can clearly see EPO is equal to OHE. OHE you can write it as OHE can be written as OHP plus PHE. So that means this particular angle you can write. So this particular angle you can sum up. So OHP plus PHE is actually equal to this particular OHE. So OHE is equal to OHP plus PHE. So here OHP is actually Z plus PHE is actually 40 degree. EPO is actually 70 degree, which we have found out. 40 degree you can bring to LHS, so that will be 70 degree minus 40 degree. That is equal to Z. So therefore Z is actually equal to 30 degree. So now we have found out that Y is 40 degree, X is actually equal to 110 degree. Similarly, Z is actually equal to 30 degree. So coming to the 8th question, they have given a parallelogram figure where it is actually written like this. They have given this as GUNS. So here this particular side is 3y minus 1. This is actually 26. This is actually 18 units and this is actually 3x. Now you should actually find out x and y in this particular 8th question. So this is actually first question in this particular 8th question. Now we know opposite sides of a parallelogram are equal to each other. So here SN should be equal to GU. So here SN is 26 and GU is actually 3y minus 1. So this minus 1 you can bring to LHS. So that will be equal to 26 plus 1 is equal to 3y. So here you can just interchange LHS and RHS. So that will be 3y is equal to 26 plus 1. So 26 plus 1 is actually 27. So this 3 you can bring to RHS. So when you bring this into 3 to RHS, it will become divided by 3. So 27 by 3 is actually 9. So 9 units is actually answer for this particular y. Now we can find the value for x. So here also SG will be equal to NU because opposite sides are equal in parallelogram. So SG is actually equal to NU. So SG is 3x which is equal to 18. So here you can easily solve this particular equation, which is 3x is equal to 18. So into 3, if you bring to RHS, it will become divided by 3. So 18 by 3. So 18 by 3 is actually 6. So here is actually x is actually equal to 6 units. Similarly, in this 8th question, if you want to solve this second question, you can follow the same procedure which I followed for to solve first question in this particular 8th question, and you can actually find x and y in this particular second question. Here also they have given diagonals in this particular parallelogram, where actually this is a parallelogram which they have given, and this is actually diagonal which they have drawn. Here this particular diagonal and this particular diagonal will always bisect each other in a parallelogram. So you should remember that. So here this particular line should be equal to this particular line, and this particular line segment should be equal to this particular line segment. So because diagonals are bisecting each other. So here this is actually given as x plus y, and this is actually given as 16, and this is actually given as 20, and this particular side is actually given as y plus 7. Since diagonals bisect each other in a parallelogram, here x plus y is actually equal to 16 and y plus 7 is actually equal to 20. Now you can easily solve this particular equation. So if you bring this plus 7 to right hand side, it will become 20 minus 7, which is actually equal to 13. So you have got y as 13, that you can actually solve in this first equation. So that will be equal to x plus 13 is equal to 16. So you can bring this 13 to right hand side. So that will be x is equal to 16 minus 13, which is actually equal to 3. So here x is 3 and y is 13. So coming to the 9th question in this particular exercise, you have 120 degree given here and you have 70 degree given here. Here two particular parallelograms are actually merged each other in a certain way. So here this particular angle is actually x. So this x you should actually find out. Here you can see, according to a property of parallelogram, adjacent angles will be equal to are actually supplementary. That means if you add adjacent angles, it should be equal to 180 degree. So here angle K plus angle R should give you 180 degree. So angle K is actually 120 degree plus R is there as it is which is equal to 180 degree. So if you bring this 120 degree to RHS, it will become 180 degree minus 120 degree, that is actually equal to 60 degree. So now you have got the angle R as 60 degree. So here this particular angle, which is ESI or KSI, is actually equal to the opposite angle. So angle KSI is actually equal to R. So opposite angles in a parallelogram are always equal. So since R is actually equal to 60 degree, so KSI will also be 60 degree. So this you can take as KSI, or you can take it as ESI. Now similarly SEC can also be equal to 70 degree, because this particular CLUE is also a parallelogram. Since CLUE is a parallelogram, opposite angles should be equal. So here CLU should be equal to UEC. So here you can see that CLU, this particular CLU is actually equal to UEC, this particular angle. So this particular angle is actually equal to 70 degree. So here this is equal to 70 degree. Now you can easily see in this particular parallelogram, this is actually forming a triangle. Now you know the angle S, you know the angle E, and you also know this particular angle. This particular angle you don't know, you should actually calculate this. So here you have found out that S is 60 degree and E is actually equal to 70 degree. In triangle EES, so this particular point we can name it as O. So in this particular triangle EOS, we know that if you add all interior angles of a triangle, that should be equal to 180. So in triangle ESO, angle S plus angle E plus X should be equal to 180 degree, because interior angle, sum of interior angles of a triangle is equal to 180 degree. So S is 60 degree, E is actually equal to 70 degree. So 60 degree plus 70 degree plus X is actually equal to 180 degree. 60 plus 70 is 130 degree. If you bring that 130 to RHS, it will become minus 130 degree. So 180 degree minus 130 degree, which is actually equal to 50 degree. So the value of X in this particular 9th question is 50 degree. Coming to the 10th question, they have given this particular figure and they have actually asked whether this is a trapezium or not. They have given this angle as 100 degree and this angle as 80 degree. So these two adjacent angles, sum of these two adjacent angles are actually equal to 180 degree. Then that shows this particular line is actually parallel to this particular line. So this shows at least one pair of line segments are parallel to each other in this particular quadrilateral. Hence, this particular figure is actually a trapezium. So this is actually a trapezium. So coming to 11th question, they have given this particular quadrilateral ABCD, and they have also given that AB is actually parallel to DC, and they have given this particular angle as 120 degree, and you should actually find the angle C. So here B and C, if you add them together, that should be 180 degree, because here you can see AB is parallel to DC. So this particular B and C, when you add them, they should be equal to 180 degree. That means adjacent angles should be 180 degree, because those two lines are actually parallel to each other. So AB and DC are parallel to each other. So B and C should be supplementary to each other. So that means if you add C and B, you should get 180 degree. So here C plus 120 degree will be equal to 180 degree. So if you bring this 120 degree to RHS, then it will be equal to C will be equal to 180 degree minus 120 degree, which is actually equal to 60 degree. Similarly, you can solve the 12th question in this particular exercise as well. So there also they have given the condition of parallel, where when two lines are parallel to each other, then the adjacent angles should be supplementary. So if you add them, you will get actually 180 degree as answer. So using this particular condition, you can easily find out the answer for this particular 12th question. So now let us actually move to exercise 3.4. So coming to the first question in this particular exercise 3.4, you have 8 question in this particular first question, and that is actually true or false. You should actually state these statements are true or false. So coming to the first statement, that is A. So there they have given all rectangles are squares. It is actually false. So the answer for A question is false, because all rectangles are not squares. But square can be a rectangle. In rectangle, only opposite sides are equal. But in squares, all sides should be equal. So all the time rectangles cannot be a square. So false is the answer for this particular A question. Coming to the B question, they have actually asked all rhombuses are parallelogram. In rhombus, we have all sides equal to each other, and also we have that opposite sides in a rhombus is actually parallel to each other. So rhombus can also act as a parallelogram. So answer for this B question is true. Coming to the C question, they have actually asked all squares are rhombus and also rectangles. Yes, square can be a rhombus, square can be a rectangle, because in square also all sides are equal and opposite sides are parallel. So it can become a rhombus. And similarly in squares, opposite sides are equal and all angles are equal to 90 degrees. So square can also become a rectangle. So they have given a true statement. Hence answer for C is actually true. Coming to the D question in this particular first question, they have given all squares are not parallelograms. But actually that is false, because all squares are parallelograms. Because in squares you can see opposite sides are parallel, opposite angles are equal. In fact, all angles are equal and all sides are equal. So that is actually satisfying all the properties of parallelogram. So square is always a parallelogram. But here they have asked sometimes square is not parallelogram. So that's why all squares are not parallelogram is actually a false statement. So answer for this D question is false. Coming to E question, they have given all kites are rhombuses. No, sometimes kites cannot be rhombuses. So for this E question, the answer is false. Coming to F question, they have given all rhombuses are kites. Sometimes all rhombus can be kites, because adjacent sides in rhombus are equal. In fact, all sides in rhombus are actually equal. So rhombus can be one of the kite. So answer for this F question is actually true. Coming to G question, they have given all parallelograms are trapeziums. Yes, because all parallelograms will be having opposite sides parallel to each other. And condition for trapezium is at least one pair of line segments should be parallel, and in parallelogram two pairs are actually parallel to each other. Like both the opposite pairs are actually parallel to each other. So that can also be a trapezium. So parallelogram can be a trapezium. Hence answer for this G is true. Coming to the H question in this particular first question, they have given all squares are trapeziums. So in trapezium, at least one opposite pairs of line segments should be parallel to each other. In squares, opposite sides are always parallel. So square can also be a trapezium. So answer for H question is true. So coming to the A question in this particular second question, in this particular exercise 3.4, they have given identify all quadrilaterals which have four sides of equal length. Means in a quadrilateral, all four sides should be equal. So you should identify all such kind of quadrilaterals. So answer for this A question will be rhombus, because in rhombus all four sides are equal. So another example for this A question will be square, because even in square all four sides will be equal to each other. So the answer for this A question in this second question is rhombus and square. Coming to the B question in this particular second question, they have given four right angles. That means in that particular quadrilateral, all four angles should be equal to 90 degree. And only rectangle and square has all its four angles equal to 90 degree. So the answer for this B question in second question is rectangle and square. So coming to the third question in this particular exercise, there are four questions in this particular third question. So they have given different questions how square can be those things. So coming to the first question, how square can be a quadrilateral. Here if we take a square, then we can see there are four sides, like four line segments are actually forming a square. So here square can be a quadrilateral because this particular polygon have four sides in it. So this particular square can be a quadrilateral. So here you should actually explain this thing in first question. So since square has four line segments, so since square has four line segments, hence it can be a quadrilateral. So this can be your explanation for first question. So coming to the second question in this particular third question, they have asked how square is actually parallelogram. So here you can see opposite sides are parallel to each other. So opposite sides are parallel. Similarly, here I will write opposite sides. So opposite sides are parallel to each other. Opposite sides are equal. And also opposite angles in square is also equal. So based on all these properties of square, you can actually say square is also a parallelogram. These explanation you should actually give for this second question in this particular third question. So coming to the third question in this particular third question, how can a square be a rhombus? So in rhombus all four sides should be equal. So even in square all four sides are actually equal to each other. So square can also be a rhombus. This particular explanation you can give to third question in this particular third question. Coming to the fourth question in this particular third question, they have given how square can be a rectangle. In rectangle opposite sides are equal. So even in square opposite sides are actually equal to each other. So here also opposite sides are equal. And also in squares all angles are equal to 90 degree. So here in square also all angles are right angle. So that shows a square can also be a rectangle. So this is actually the explanation for fourth question in this particular third question. Coming to the fourth question in this particular exercise, you have three questions in this particular fourth question. So coming to the first question, they have given name the quadrilaterals whose diagonals are bisecting each other. So you should name all those quadrilaterals in which diagonals will actually bisect each other. Since rhombus has all sides are equal, so in rhombus diagonals will actually bisect each other. So one example might be rhombus, one example is rhombus, the other example is rectangle, and another example which you can give here is square and also parallelogram. Because even in parallelogram, since opposite sides are equal, diagonals will bisect each other. So I'll just write the symbol of parallelogram like this. So answer for this first question in fourth question is rhombus, rectangle, square and parallelogram. Coming to the second question in this particular fourth question, they have actually asked name the quadrilaterals whose diagonals are perpendicular bisectors of each other. So only in square and rhombus you can find perpendicular bisection. In all these four quadrilaterals, diagonals will bisect each other, but only in rhombus and square diagonals will bisect each other in such a way that they are perpendicular to each other. So answer for this second question is rhombus and square. Coming to the third question in this particular fourth question, they have actually asked name the quadrilaterals whose diagonals are equal. So only in rectangle and square diagonals will always be equal. So in rectangle and square diagonals are equal to each other. Coming to the fifth question, they have asked why rectangle is a convex quadrilateral. So if you refer my part 1 video of this particular quadrilaterals chapter, I have actually explained what are concave and convex polygons. So let's say we have a polygon like this. So if a polygon is actually having one of its point interior to it, then this particular polygons will be concave polygons. So if all points are exterior of a particular polygon, then that particular polygon is actually concave polygon. Similarly, a convex quadrilateral is that quadrilateral which has all its points exterior to that particular quadrilateral. So in rectangle, you can easily see all the points are actually exterior to this particular quadrilateral. Hence, all the points are exterior to this particular rectangle. Hence, rectangle is a convex quadrilateral. So this explanation you can actually give in your own words. Coming to the sixth question in this particular exercise. So here they have actually given a triangle ABC, and this particular O is there on this particular AC line segment. So this O is actually midpoint to this particular A and C. They have actually asked why this particular O is actually equidistant from B, A and C. Here you can easily see O is midpoint to this particular AC. Hence OA is actually equal to OC. Now you can actually draw a line from B to O, and you can actually extrapolate this, and you can actually extrapolate this particular line as well. So we have extended those lines and we have formed a rectangle, like imaginary rectangle. So here in rectangle, diagonals will actually bisect each other. So here this particular line segment should be equal to this particular line segment. That means this particular line segment should also be equal to this particular line segments. And in rectangle, diagonals are actually equal to each other. So let's say this is actually D. Here in rectangle, diagonals will be equal to each other. So here AD is equal to BC, that is opposite sides. AC is actually AB is actually equal to DC. Similarly, diagonals are equal to each other in rectangle. So AC will be equal to BD. And in rectangle, diagonals will bisect each other. Hence, AO is equal to OC, and also OB is equal to OD. Since AO is actually equal to OC and OB is actually equal to OD and AC is actually equal to BD, hence OB will be equal to AO and OC. So OB will be equal to AO and also OC. So this actually shows all these 3 points A, B and C are equidistant from this particular point O. So this is actually explanation for the sixth question. This you can actually write in your own words. So this is all there in this particular video. So I have made 3 parts of this particular quadrilaterals chapter. So if you want to understand this quadrilaterals chapter properly, then please watch all 3 parts starting from part 1 till part 3. So then you can understand this third chapter very neatly. So like this, I will be uploading more and more physics, chemistry, mathematics related videos starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.